Hey guys, in this lesson we would understand right triangles trigonometry. Let's first understand what are the basics of trigonometry and what does the term basically mean. Trigonometry is the branch of math that relates angles and side lengths of the triangles. We will be dealing with two types of triangles. One is right triangles and one is acute triangles. In this unit we would focus on right triangle trigonometry. We know right triangles are triangles that contain one of the angles equal to 90 degree or right angle. That's why the triangle name is right triangle. Here in this triangle, vertex A represents angle A, B represents angle B, C represents angle C. Side opposite to the vertices are written with lowercase alphabet, same as the alphabet used for the vertex. So if this is uppercase A, this is lowercase a. This is uppercase B, this is lowercase b. If this is uppercase C, this is lowercase c. So uppercase A, B and C represent angles, whereas lowercase a, B and C represent side lengths. So in case we have to find out side lengths using the angles, or vice versa, that is finding angles with the help of side lengths, then what comes handy is trigonometry, because trigonometry helps us find the relationship between the side lengths of a triangle and the angles. And then we can use that relationship to find out any unknown side length or unknown angle. There are three types of trigonometric ratios that are going to be used for right angle trigonometry problems. The first is called sine ratio, second is called cosine ratio, and third is called tangent ratio. Short form representations of these ratios are: sine ratio is represented with sin, cosine is represented as cos, and tangent is represented as tan ratio. An important thing to note is that these ratios are described for a given angle in a right triangle. Also, because ratio means something over something or something divided by something, in trigonometry, when we write down trigonometric ratios, we take the ratios of side lengths. Therefore, all the ratios of side lengths are described for a given angle in a right triangle. Let's understand this with a diagram. If this is the right triangle ABC and these are their respective side lengths, A, B, C, and let's say we have to write down sine ratio, that is this one, for angle A, because ratios are always described for a given angle. So let's describe sine ratio for angle A. How do we write it down? We write down sine of angle A. So we write down this ratio, sine, angle is angle A, would be equal to opposite over hypotenuse. Now what is meant by opposite and hypotenuse is when we are writing the trigonometric ratio for a given angle A, then for angle A, the side that is opposite to angle A is called the opposite side. The side on which angle A lies is called adjacent side, and the side that is opposite to 90-degree angle, that is the right angle, is always going to be called hypotenuse. So sine of angle A is described by the ratio opposite side divided by hypotenuse side. And this is true for all the right triangles, that sine ratio for any angle is described for that angle's opposite side over hypotenuse side. Similarly, if we want to write down the cosine ratio of angle A, cosine is always described by adjacent side and hypotenuse side. So cosine of angle A is going to be equal to adjacent side divided by hypotenuse side. Then comes the third ratio, that is tan A. Tan ratio for an angle, because we are again talking about angle A, is described by opposite and adjacent side. Therefore tan A is equal to opposite side divided by adjacent side. So sine A is equal to lowercase a over b, cos A is equal to lowercase c over lowercase b, and tan A is equal to lowercase a over lowercase c. There is an easy way to remember all these ratios with respect to the given angles. And how do we say it is SOHCAHTOA. So SOHCAHTOA. So S stands for sine, O stands for opposite, H stands for hypotenuse. So we can say sine is the ratio of opposite side over hypotenuse side of the right triangle. C stands for cos, A stands for adjacent, and H stands for hypotenuse. That means cosine of an angle is the ratio of adjacent over hypotenuse. TOA, T stands for tan, O stands for opposite, and A stands for adjacent. That means tan of an angle is the ratio of opposite and adjacent side. Let's take up few examples to understand these ratios. Let's say we are given this right angle triangle and we are asked to write on all trig ratios for the given angle. Now we are given angle P that is equal to 25 degrees and we are supposed to write down sine, cosine and tan ratios. That is meant by writing all trig ratios. The first thing we would have to do is find out what is the opposite side, adjacent side and hypotenuse side with respect to angle 25 degrees. Hypotenuse is always a side that is opposite to 90-degree angle. So we would first mark the hypotenuse that is represented with side PR. The other two sides, opposite and adjacent, are represented with respect to the given angle. So for 25 degrees angle, QR is the opposite side, and for 25 degrees angle, PQ is the adjacent side. Therefore, if we have to write on sine ratio for 25 degrees angle, we put sine 25 is equal to, because sine comes from so, and sine is the ratio of opposite and hypotenuse. So sine 25 would be equal to QR side, that is the opposite side, over hypotenuse side, that is PR. Next ratio we have to write down is cosine 25. Cosine is ca, that means cosine of an angle is adjacent over hypotenuse. Since we have to describe cosine for same angle 25 degrees, adjacent side is PQ and hypotenuse side is PR. Similarly, we can write down tan ratio for angle 25 degrees and that would be equal to opposite over adjacent, because tan is TOA. So tan of an angle, that is tan of 25 degrees, is equal to opposite over adjacent. So for 25 degrees, opposite side is QR, and for 25 degrees, adjacent side is PQ. This is how we write down all the trigonometric ratios for the given angle. Let's say in the same triangle, if we were given this angle, that is angle R, and we were supposed to write down all trig ratios for angle R, then in that case, the first thing was to mark opposite and adjacent side for this given angle R, because PQ is now going to become opposite to 65 degrees angle, so this will be marked as opposite, and since angle R or 65 degree lies on this side, so this will be called adjacent for angle 65 degrees. Hypotenuse would always stay hypotenuse because hypotenuse is the side length that's opposite to 90-degree angle. Therefore, the trigonometric ratios for angle R will be sine 65 degrees, because we are writing the trigonometric ratio for 65 degrees. So here the angle will change from 25 to 65 degrees. Sine 65 degrees means the ratio is opposite over hypotenuse, and opposite for the blue angle is side PQ, that we would write down as PQ over PR. Similarly, cos 65 degrees would be adjacent, which is QR, over hypotenuse PR, and tan 65 degrees would be equal to opposite over adjacent. So opposite for 65 is PQ and adjacent is QR. Therefore, we get PQ over QR. And this is how we write down the trigonometric ratios. In this particular example, we just wrote the ratios with respect to the side lengths using the alphabets. What if we are given the side length values? Then how do we write on the ratios? Let's understand that with an example. Let's say we are given a question where we are given the triangle ABC, right angled at angle B, and we are given side length AB as 4, side length BC as 3. We're not given any units, so we will just think that this is 4 units and this is 3 units. We have to write on all trigonometric ratios for angle C. All trigonometric ratios means we have to write on SOHCAHTOA for angle C. So the first thing we would do is identify which side is opposite, which side is adjacent, and which side is a hypotenuse for angle C. We know hypotenuse is always the side length that is opposite to 90-degree angle, so this is going to be the hypotenuse. For angle C, this side is opposite, because this is the side opposite to vertex C, and for angle C, this side is adjacent because angle C lies on side CB. Now we are given the value of side length AB or the opposite. We are given the value of adjacent or the side length CB, but we are not given the value of hypotenuse. So the next thing is to find out the side length for hypotenuse. Since we know this is a right angle triangle, we can use Pythagorean theorem to find out the side length AC. As we know, AC square is going to be equal to AB square plus BC square. This comes from Pythagorean theorem, that is hypotenuse square is equal to opposite square plus adjacent square. We are looking to find out hypotenuse. We are given opposite side and we are given adjacent side. So we would substitute opposite as 4 and we would substitute adjacent as 3 and we would get the value as 16 plus 9 equal to hypotenuse square. Since we're just looking for hypotenuse length, we would move the square on the other side. So hypotenuse becomes square root of 16 plus 9, that is 25, which is equal to 5. Therefore, this hypotenuse side length that we've got is 5. Now let's write down all the ratios for angle C. Sine angle C is equal to opposite over hypotenuse. Opposite is 4, hypotenuse is 5, so we get 4 over 5. Next we have is cosine angle C. Cosine is adjacent over hypotenuse, that is equal to 3 over 5. Next we have is tan C. Tan is opposite over adjacent, that is equal to 4 over 3. And this is how we write down trigonometric ratios for any given angle when we are given the side lengths.